Good afternoon, everybody. Thank you for joining our presentation today. I have just one reminder. So this presentation is going to be recorded. So in case that you need it afterwards, we will share it with you. I will just please ask you to keep all the microphones mute during the presentation, microphones and cameras, please. So we will not disturb the presentation of our colleagues. If you have questions during the presentation, I will ask you to please put it in the chat. So at the end of the presentation, we will have 15 minutes to discuss about the questions and answers if you have some questions related to the project. So we will start this presentation first. It will be me who will do an introduction of what the project RightWeight is. What is the Interreg project? Then my colleague Manuel will discuss about the challenges that we want to solve during this project. Then I will come back, will explain you a little bit about the infrastructure that we have, the expertise that we can provide, and how we will fund the companies that are participating. And finally, our colleague Joren will present success stories of previous projects that in which Flanders Make was involved. And as I said, we will have 15 minutes for question and answers in the case that you are interested in the project. So let's start here. So the first part is what is the Interreg? So the Interreg program is a program that aims at deliver concrete results to the region to improve the quality of life of the citizens and to reduce the disparities between different regions. So we want to have a reduction of disparity. So in the last years, it was focusing on innovation in reducing carbon production and in the better resource of materials, so to produce new materials. One of the important aspects of the Interreg projects is to maximize the interactions between different regions, but also between different sectors. In this particular project, what we want to ask is to maximize the interaction between auto and aero sectors. So as some of you know, aero sectors have high-level materials. They know how to provide lightweight solutions. However, they are not as efficient as automotive industries to produce for mass production. So when we are talking about low cost and mass productions, automotive are much more efficient. So the objective here is to maximize the synergy between the two sectors and the companies in the region to have an efficiency as in the auto sectors, but also the lightweight solutions as in the aero sector. So the concept and objectives of this project is to have environmental and affordability targets. So we want to have lightweight solutions, but also that are cheap. We want to support aero and auto sector. So we want both kind of sectors to be there. So all the transportation. And we want to create also an ecosystem so that the companies in the region will interact between each other, and we will maximize the business between companies in the region. So the activities that we have in this project are three. The first is the challenge-driven competition. So this is already identified. So there are big companies that are defining challenges in the production of automotive or aerospace. The challenges will be presented by Manuel, as I told you before. And the objective is that the small SMEs or SMEs should be able to help these companies to solve those challenges. So the first part is to define the challenges. So this is already done. In the second part, SMEs will try to solve those challenges. And to solve those challenges, we as research centers, we are going to provide you some help. So we will provide you field labs and training, so our expertise and our labs to develop these solutions. This is a presentation I will do it after the presentation of the challenges. And then the last but not least is important is that we want to create a database of companies in the region. So when you need a product of a services, you will have you will identify them easily. So this is the three aspects of the project. I will let Manuel present about the challenges, and then I will come back to present you about the infrastructure.
Okay, thank you, Gabriel, for the introduction. I will quickly present my screen. Good. So the last half year, we at Flanders Make, together with a lot of the other research partners, have looked a lot to the automotive and aerospace OEMs and tier 1 suppliers to see what they're challenging, what challenges do they face in their production and their design process with regard to lightweighting, just like Gabriel introduced. As you can see here, a few of the companies, which are in this case actually not Flemish companies or not Belgian, but rest assured, there are actually also quite a few Belgian ones in there. So these companies have given their challenges, and we have categorized them in 5 different fields. So in my next slide, I will give a short overview about the different challenges in each field. First field is material supply and development, so anything about lightweight materials and characterization. Secondly is characterization and modeling of a problem, so how to do, for instance, certain optimizations of your design. Third category, design and smart function, so specific parts that need to be designed in a certain application. Then there were some challenges given to manufacture something. We have some cases where the part itself was very lightweight, very performant, but not the machinery was not there to really upscale the application. And then finally, everything about recycling. So we also see that definitely ecological design and circular design are things which are also of interest of these tier 1 suppliers. Good. What I will do in the next slides, I'll give you an overview of the different challenges in each and every domain. So first and for all, as an example, but you can see here we listed quite a few. Stelia Aerospace, it's a Dutch company. They make these kind of interior cabins. We all know it, the small toilet from the aircraft, the places where you put your luggages. And they're actually actively looking to more sustainable and green composites for the interior of an aircraft. They're looking at bio-based materials maybe. So basically, yeah, any type of inspiration or let's say demonstrator we can develop for them is very much of interest. But of course, also other challenges are applicable. As you can see on the left-hand side, we indicated it's either an aerospace or an automotive challenge. And on the right-hand side, I added the Flanders Make logo to give you already really related to the challenge some information about what Flanders Make has on services or on expertise. And here specifically, Flanders Make can assist the SMEs. So all of you in, for instance, material characterization, we have a lot of test machines to verify the performance and then the characterizations of a certain material in a certain shape. We have quite a lot of expertise in the joining of assemblies, so specifically composites, how to join them together. Okay. Second category of challenges, again, I present here a small overview, are all about characterization and modeling. Here we actually saw that most of the challenges came in from the automotive sector. This specific challenge I'm highlighting here is from actually a Belgian one, a very big OEM on agricultural devices. And as you can see, they had some challenges on further how to design with composite panels. So it's really a design thing where you have these kind of metal sheets at the moment in these the carrosserie of the agricultural device. They would like to see how we can optimize the plies. How should we redirect the plies? Can we identify how the shapes would look like with these kind of ribs? But also, for instance, certain situations where a kind of a metal rod should be connected to a bunch of plies. How can you optimize the fiber direction? All virtually and all with modeling. So also here within Flanders Make, we have quite a lot of competences on modeling composites. We can really assist you there. If needed, we can do tests of certain materials and assemblies. So we are here to help on these different factors. Third category, design and smart function. There is one case I highlight here. It's a very specific interior panel of Snooks Automotive. So Snooks Automotive is a tier 1 supplier for the automotive industry. And they have basically a challenge to have this new type of interior panel of, let's say, a van, which separates the driver from the back end of the car. And they're looking at a new design, a new lightweight design, which has a, let's say, a kind of a goal to be 30% lighter. They will also like to do a lot of testing, and specifically defined element analysis testing. So that's again another example of a challenge. Again, Flanders Make here can help with assembly of and how to assemble and bond different components together, part testing and validation, but definitely also the simulation side of things. Good. Third category, or fourth, sorry, already, manufacturing and assembly. So this is actually also from a Belgian tier 1 aerospace company, and they produce large aluminium panels of an aircraft. So really the body panels, so to speak, in aluminium. The part itself is very lightweight. It's very high-end aluminium alloy, but the production method is too slow for upscaling. So at the moment they have these kind of open molds, which they provided for us for this challenge. Not the mold, but the images. And they put the entire mold into an oven, and they're looking actually at a process where they can stack multiple of these metal plates on top of each other, these aluminium plates, and have a more controlled heating and forming of the aluminium sheets. As you can see on these specific challenges, there is not a direct link to the infrastructure or the competence of Flanders Make. Of course, we can always negotiate certain tests, but also here I would like to highlight that there's actually quite a bit consortium of other European partners in France, in the Netherlands, who can definitely also have their infrastructure available for you to do the proper testing and validation of the new workflow. In this case, a new manufacturing equipment. Okay. And then finally, it's all about recycling. So there's a customer, there's no indication of the name here, but it's again a Dutch company who is more interested in automotive lightweight parts based on post-consumer recycled plastics. So coping with the variability of the materials, how can we design and engineer new parts with these kind of plastics? It should be cost efficient. Okay. Good. All these challenges are described more into detail, so I now highlighted only a few because I don't have that much time, but all of these challenges are here on the link of the RightWeight website /challenges. You can directly access that. You can scroll through, open each and every individual challenge and see which one would fit most to your expertise and competences. Because if you see a match and if you have a good or a clever solution, it's definitely we are there to help and to really create for you a nice demonstrator, a nice solution for the company and bring you into contact with them. Okay. Good. That's it from my side. If there are any questions, I would recommend to put them either in the chat or keep them until the end of the presentation, and then we'll be there to answer them for you. Good. I think that's it from my side.
Thank you, Manuel. So let's move to the next part of the presentation. So as I told you before, if you identify challenges that are interesting for you, so what I suggest is that you see if the solutions that you provide are adapted, and if you think that you can arrive to TRL7 on that solutions. So now I will explain you how we will help you. So there is something that we call the field labs or expertise, in which we are going to help you. So first of all, what are the field labs? So the field labs are laboratories or test benchmarks where we can replicate real life conditions, and they aim at helping you to achieve a TRL7 in your solutions. So how this will work is, as you say, the champions or OEMs are going to define industrial challenges. You, as SME, will bring solutions with low TRL, let's say 4 or 5, And with our help in our field labs, we will assist you to develop a high TRL solution. To show you more or less what we can do is I have some examples of field labs. What the first field lab is, for example, helping you in generative design for lightweight structure. So one of our expertise is in topology optimization. So here, for example, we define some constraints for lightweight. We generate different designs and then we compare it. We identify that automatically generating the designs is good because you can find solutions that are not evident for if you do it as a person. So the computer can find solutions that a normal person will not find, and we can guide the designer toward interesting solutions. So here, for example, you see an infinite number of solutions, and we identify the behavior of these solutions regarding stiffness or mass. Here we have some success stories. Joren will show you some success stories, but here, for example, we can see that through our methods, we arrive to reduce the weight and the cost of the designs. So if you have one solution that can meet the challenges proposed by the champions, yeah, we can help you to achieve the result that you are expecting. We can help you also. So for the first one is design. The second one is manufacturing. So this is not Flanders Make, but another partner involved in the project. We can provide expertise in manufacturing. So we know how to do injection molding and how to do composites. So it's something that is our expertise. We know how to position the fibers in the material. So it's something that is outside of the expertise of our lab, but it's the expertise of one of the labs involved in the project. So if you need manufacturing assistance, it's something that we can provide. Then another thing that we can provide is one of our partners in Italy who has these facilities, is that if you have a material that is already good, but you need to do some tests for this material, we have several testing facilities, but one that I want to show today is the reaction to the fire lab. So we can test how is the behavior of your component to the fire. So this is something that we can do, and we can certify that this reliable for production for the aerospace or for the automotive industry. So this is something that we can do for you. And then another expertise. This is in the lab of Flanders Make. We have some expertise in repair and reinforcement of composites. So we know how to repair them. It's something that we have some expertise. And it's quite particularly important here because we are aiming at environmentally friendly solutions. So we don't want to change all the components. We want to learn how to repair those components. So if one of the challenges is aligned to this, and you have one solution that is aligned to this, for sure our lab can help you and assist you to develop a solution that met the requirements of the big companies. So this is a brief example of the field labs. Something that you have to know is that this field labs is a first overview based on the expertise of our labs. Those field labs can be adapted according to your requirements. So if you have a solution that needs some testing or need a combination of this testing and repairing, it's something that we can do as part of our project. And they will be adapted depending on the SMEs that participate in the project. We cannot go too far from what we are showing here, but in general, we can adapt our labs to help you and to be aligned with the requirements of both the challengers and the SMEs. So for the application process, so the first part was to define the challenges. This is already done and are there. So the second part is to find the SMEs that can meet or can propose the solutions to solve those challenges. And so this is why we contact you. And the applications are now open. So the idea is that you should apply before the 1st of October. All the information about the application is in our webpage here in the link. I will share this slide with you at the end of the presentation, so you will have all the information there. But yeah, all the information about the application process is there. There are some key points that I want to mention now. So at least a first check if you are eligible or not. The first is that you have to be located in the region. I think most of you are from Belgium, so you are definitely in the region. And then you have to follow some rules from state aid. So if you already involved in other projects and you receive more than 200,000 euro in the last 3 years, maybe you will not be able to participate. But in the other side, if you didn't receive more than 200,000 euro in the last years, you can participate in the project and it will be aligned with the state aid rules. Then we have some guidelines and regarding the help that we can provide. So just to know, we are not going to provide you money to do this project. We are going to provide expertise and facilities. I will explain this in the coming slides. But yeah, this is the help. It will be of a voucher. So you will receive some vouchers and you can use it in the lab that met your interest the best. Something that is important is for the evaluation. So we expect as many SMEs to participate in this process as possible. To evaluate, we want to be as clean as possible and as clear as possible. So the first is the 30% of the evaluation will be the relevance of the project. So how aligned are you with the requirements of the challengers? We don't want to help companies that provide interesting solutions but are not aligned with the objectives of the project. The second part is the implementation of the solution. So your idea could be very good, but if we are too far from TRL7, it's a solution that we don't want to get involved. The objective is to be as close to the market as possible. So we don't want to remain in the research part. The innovative aspect is also important. And finally, the impact. So the economical impact, the environmental impact. This is something that is also really important. So these are the 4 parameters and the 4 criteria that we are going to take into account when we analyze your applications. All these applications all this information is in our link. So if you don't remember something today, you just can look at it in our webpage or contact me for more information. So how we are going to help you? So we have the 2 waves, and each wave we will provide assistance to 50 SMEs. So the first 20 SMEs, so the trailblazers, will receive a help of up to 45,000 euro in help. Then we have something the other companies will consider followers. They will receive a help of 6,500 euros. As I told you before, this help will not be provided in money. We cannot provide you money, but it will be in services and installation. So if you need one specific experiment, we can use part of this budget to develop to set up the experience for you. We can provide you all the expertise in all the research from all the research partners to develop these solutions. We can provide you research, but also the help to define the road to the market. So this is for the first 20, it's 45,000 euros. And the objective is to arrive to TRL7. So if your solution is too far from TRL7, it will be difficult to be selected as the first trailblazers. I'm not sure, it depends on how many companies applied, but in general, the ideal project is something that with this kind of help can arrive to TRL7. Then we have other, that is the followers, so the companies that are not selected in the first round as the trailblazers, they will receive 6,500 euro. And then the objective is to improve the TRL of at least 1 point and to have a clear plan to TRL 7. So in one, we will arrive to TRL 7, in the other one, we'll have a plan for TRL 7. Regarding the waves, so the first wave will start, so the call for application is right now. And then we have, in November, we will start with the incubation period. So if everything, if you get selected, starting from November until the end of 2022, you will be incubated as a company with us. You can come to our labs, you can implement your solution in our lab, and we can provide you all the expertise that you need. The second wave is next year, and it will start the incubation period on May. So something that is important to keep in mind is that if the challenges that are shown today are not aligned to your solution, there are new challenges that are coming on January. So there is a possibility that if you don't have any solution adapted for this wave, it can be still adapted to the next wave. Yeah. So how to apply is just a summary slide here. Is you can go and identify the challenges, look at the challenges, and see how your solutions are adapted. Find the information about the project and on the web page, but also you can contact me. So if you have any questions, don't hesitate. We are here for that. And then you can fill the application form. Yeah, it's a summary slide. The application form is quite lean. Our objective, it was not to make something bureaucratic and difficult to fill. We understand that we are here to help you, so we want to keep it as easy as possible. This will include some general information. Yeah, what is your company about? Then you have to certify that you are eligible for receiving this budget. So this is something that we cannot verify by yourself, but you have to certify us that you didn't receive help and you are aligned with the state aid regulation of Europe. And then you have to define and explain what is your solution. So you have to detail what is the solution that you want to provide, what is the status, what is the roadmap, and what do you need to achieve TRL 7. And based on this information, we will do the evaluation to see if the solution can be taken into consideration in this project or not. So this is a summary of the application process. As I told you, at the end of in the question and answer session, we can provide you more information about that. But I hope this introduction was clear for you. So I will let my colleague Joren to present some success stories of previous projects. So if what we can do for you in the field labs is not clear, maybe these success stories will show you why it is interesting to join and collaborate with us.
All right. Thank you very much, Gabriel, for the introduction and the overview of the application. I will present or highlight 2 success stories from our labs at Flanders Make to give you a quick idea of what Flanders Make can do. So these success stories are from the past of Flanders Make, and the first one is on the fast curing and reversible adhesive bonding. So adhesive bonding in itself is already a lightweight connection method, but the current epoxy adhesives, they take a very long time to cure, sometimes up to 48 hours, depending on the adhesive and the conditions, and they often require an oven as well. And also applying a primer is not suitable for every material surface, and the primer as well adds an extra step after cleaning. And then when the product needs to be repaired or recycled, your adhesive joints can be very difficult to disassemble as well. So therefore, the Joining and Materials Lab at Flanders Make developed a method to achieve faster curing and easy debonding at the end of the product life cycle. And so this is achieved by adding magnetic particles mixed into the adhesive, so that, yeah?
Sorry, I cannot see the screen. I'm not sure how it is with the rest of the people, but to me it's still black.
Here I can see it actually.
I can see it as well. Thank you.
Ah, okay, then it's on my side. Sorry.
All right. Sorry, Manuel. And okay. So yeah, the accelerated curing can be achieved by adding magnetic particles into the mix with the adhesive, and then by applying an induction tool, the interface itself can be heated from within, which significantly speeds up the curing time. And also, instead of applying a primer, we can use an atmospheric pressure plasma to clean the surface and to activate the surface energy in just one step and without adding any chemicals to the joint. So effectively, both of these solutions reduce the time and so the cost to make the joint, and also help reduce the ecological impact of the product. So how fast can this be done? Well, the curing itself can be done in about 15 minutes. So versus 48 hours, that's quite a speed up. Of course, it also comes at a bit of a price, which is in the strength of the joint. And there with the added particles, we can reach 40 to 90% of the original strength with the classical method of curing. But this is enough, more than enough for most applications. And it can be applied to epoxy and thermoplastic hot melt adhesives as well. And then the bonding as well is being done by the same procedure, so by reheating with the induction tool the interface itself, and there this reduces the strength of the bond very rapidly, and in about 2 minutes you can take the joint apart. So that makes it a lot easier to repair and recycle. Where can we assist with these solutions? The Joining and Materials Lab has extensive expertise in the selection of the adhesives and the particles, and can help you optimize the particle content as well. We also have some optimization models for the design of the induction coil, for instance, and also to know the temperature at the interface of a moving coil. So effectively that lets you know how fast the induction tool can be moved over the surface in order to get the best quality curing. And additionally, we can also provide guidance on the best application of the plasma treatment of the surface. And when the prototype is built, our lab can perform mechanical testing and validate it and validate the adhesive joint in a climate chamber. Okay, and then we can already move on to the second success story, which is from the Co-Designs Lab. And this focuses on the weight and also cost reduction of a vehicle panel. And the Co-Designs Lab will focus more on the virtual solutions. So a lot of simulations in this case. And in this example, we have a body panel for an agricultural vehicle, and it's made up of 2 skins. The initial design was already used as part of the machines and fulfills all the technical specifications, but the company Vitalo wished to explore the possibilities to reduce the weight of these panels. And so at Flanders Make, a finite element model was made and quickly showed that there still exists quite a margin for improvement. And so different design options were then generated and compared with the Conceval workbench, which is a dedicated software tool which was developed at Flanders Make, and that allows to evaluate design concepts to multiple objectives. And so in this case, the focus is on the technical requirements, the weight and the cost of the panel. And so if we look at the results, and then several designs have been generated, and a best candidate has been selected there, for which the mass could be reduced by 20% and the cost to produce the panels by 15%. And so Vitalo then built this new design and consequently won 7 new projects from their customer. So quite a success story indeed. And then where can we assist? Well, in the structural analysis to understand the design limits, the structural optimization of a product design, so really the topology optimization or sizing optimization, and also the multi-attribute design evaluation and decision support with filtering and ranking algorithms. So that's in the Conceval workbench that I told about. And also for detailed cost evaluation, taking account of the material and scrap costs, and an activity-based cost estimation for manufacturing costs of different design concepts. So these were 2 of the past success stories of Flanders Make. I hope that gives a bit of an idea of where we can assist you in some of the challenges. And I would like to ask if there are any questions, but I think we just arrived to the Q&A session, so I will end the presentation here.
Thank you, Joren, for your presentation.
Okay.
So, thank you also, Cecile, for answering one of the questions in the chat. So there was one question, is that if Horizon 2020 is considered as a state grant. From what I know, and I think Cecile can confirm, is that projects that are considered as research projects, so as soon as you are not taking a full development on that funding, are not considered as state aid if they if they remain in the prototype phase. However, if you receive some subsidies to create a product, then can be considered as a state aid. So according to Cecile, H 2020 is not a state aid, but ERDF can consider as a state aid. But if you have more questions with these regards, if you have some doubts, don't hesitate to come to us, and I will provide you all the information that you require. I will ask our experts also here in Flanders Make and in the project to see exactly if you are able to participate or not. I don't see many questions in the chat, so if someone wants to do some questions, please, you can go.
I maybe have a small question to the audience. If you already know that you will have a certain challenge, can you raise your hand so we have a little bit of a flavor of you who has already a feeling if you will launch a challenge or a solution to a challenge? I don't see any hands yet. Then I would recommend, go to the website and dive a little bit deeper into the different challenges.
Yes. Thank you for your question, Manuel. So I don't think if there are no more questions, just please, I will send you the link to all the participants of the meeting, to the link to the web page. You will have all the information regarding the application process. That is, as I want to remind you, is quite lean. So the objective is to make it as easy as possible, so you don't have a lot of problems to participate. There you will find all the information, and if you have some questions, don't hesitate to contact us. I will provide you all the information that you require. But also our experts in the project can help us to see your particular case, for example, in case of the state aids or other problems that can happen there. So I would like to thank you for your participation. And I think that if there are no more questions, we can close the meeting right now. Thank you very much.